Hi, kids. All right, this little instructional lesson is going to be on essentially what Max Planck hypothesized and what was essentially proven true because we haven't proven it not to be true. So Max Planck was looking at, as you guys saw hopefully in that one video, he was trying to figure out why, when you heat something up, why does it always glow red first? Why not like glow green or glow blue? Why does it always glow red first and then other colors? And he essentially hypothesized that this was true. That, you know what? He knew that the temperature relates to the amount of energy, okay? And so he said, well, you know what? Maybe that the energy is related to the frequency, because, hey, if it glows red, red has a certain frequency, which is lower than green, lower than blue, so like as you heat something up at a lower temperature, it's going to have less energy, so therefore the frequency is going to be smaller. And as it turns out, he was true. He was right. So really what this is saying is that energy, because remember this H is 6.63 times 10 to the minus 34th. Okay? So really what he's saying is that energy is quantized so that it comes in like little itty bitty packets. So that rather than, the old way of thinking about light was that, hey, light is a wave. And you know what? The intensity of a wave depends on its amplitude. The energy of the wave depends on its amplitude. Think about, for example, okay, think about at least, like a water wave, okay? More energy means bigger wave, bigger amplitude. Well, that's not true with light, okay? Light, okay, more intensity, meaning bigger amplitude, just means you get more of these photons, more of these light particles coming at you. Where if you have more energy, that means you are going to get higher frequencies. So the reason that Max Planck was right was that, as you heat something up, okay, lower temperature, lower energy, so you're going to get less of this. That doesn't mean, I want to make sure you guys understand, like if you heat something up to a high enough energy here, high enough temperature, so that you would get violet light, for example, that doesn't mean you just get violet light. Okay, you're going to get lots of the other colors and then also violet light. So another way you can think of this, guys, is you can kind of think of like energy as kind of like this staircase. Okay, so that where the old way of thinking about energy and with waves was that if light was a wave, it would be more like a ramp. Okay, you could be at any level along this ramp. Okay, at least that was the thought. But if it's quantized, it's either you're at this level, or you're at this level, or you're at this level, or you're at this level. Now, the size of these steps is really small because Planck's constant is really, really, really small. Okay, but the key is that yes, it is like this. Which is also why when we represent a wave, we represent it by a photon, which is a wave particle, which, if you get questions where it talks about like the wave function, really what this is trying to just show you is that this photon is most likely going to be there. But it could be there, it could be there, but it's most likely going to be in the middle. All right, hopefully that makes sense. Bye, kids!